Hello, Natalie Tarry from Natematics. This is part of my 10-week countdown for the GCSE Mathematics in 2023. And this week I'm going to be talking about transformations in the lesson. I'm going to be going through the four main ones. Well, I say four main ones, there are four altogether. And I'm going to give a few examples of how to do them. So for the majority of this, it's all in kind of PowerPoint. There are builds, I'll promote questions as well, rather than just showing you this is how it is and that's it. I want you to be thinking as well. I've also going to add a question at the end, which is a GCSE maths question. And depending on how time goes, I may well just open up an exercise on the screen, literally using my pad and a pen on the screen sort of thing, and just sort of talk through a few things with you. Okay, so this is aimed at up to a grade 4, and it is, you will see these on high, and you may see them a higher level, but the easier sort of questions. I'm not going into negative enlargements or fractional enlargements. So I'm at the sort of bottom end of transformations. So there are 4 different ones. So as soon as you see a question about transformations, you think, okay, so is it a translation? Is it a reflection? Is it a rotation? Or is it an enlargement? So let's go through each of those individually. So a translation is where we just move a shape up or down, left or right, or any of those sort of combinations. So it doesn't get bigger or smaller. It doesn't rotate. It's not a reflection. So literally, it's almost like you've literally taken it and moved it up or down. Oh, excuse me. And so a rotation, now bearing in mind, I will go into a bit more detail of those in a little while. So a rotation is where you are turning something. So rotation is a turning. So it's what we do literally is almost like you've got a picture, you're going to fix a point somewhere and then you're going to rotate it. And depending on where you fix your point, depending on how far it's, where it's going to end up. So here's an example where I've got a rotation of this triangle is rotated to give that one there. The details that you need to give again, I'm going to go through an example in a minute. Okay, number 3 is reflection. The best description I think of with this is literally, you've done this probably in primary school. We get a piece of paper, you draw something on one half of it, fold it over, and then you sort of smudge it, and then you have a reflection. Yeah, those sorts of things. Have that in your mind when you're looking at reflections. So a reflection is literally you look at the distance from the shape to a line, and then that line is effectively the middle, so where you folded your paper. Think of it as like a mirror image as well. Now, these are much easier when you've got like a vertical or a horizontal line. When you've got diagonal lines, what I strongly suggest you do is you actually rotate your paper around a little bit. In fact, that's a great tip for any question where it involves shapes and angles. Turn your piece of paper around slightly to give it a different perspective. Right. And then what we do here is we also look at the distance from each of the points on that shape, the vertices, to that line, and it should be the same on both sides. And when you look at the lines between each of the corners, they meet this at a right angle. So when we look at this line here, and these lines here, they meet at a right angle, which again, when you've got a vertical line or a horizontal line, much easier to see, but it's probably never really explained to you in that way. Just bear that in mind. And I've got another reflection here where I have got a diagonal line. And quite often, this is where it becomes a little bit more difficult. So I wanted to show this extra one as well for you. So you'll notice that I've drawn a line from the corner to this line. Now I could have gone that way, but then it wouldn't have met at a right angle. It would have been, much less, well, actually a little bit more than a right angle. So we make sure we hit that line at a right angle. Then we complete that distance to the other side. So it's going down 2, across 2. And that is where that corner of the triangle is going to be. Now we do the same for each of the corners, the 3 corners of that triangle, and then we join them up. Okay, so when you rotate it slightly and look at it, you think, oh yeah, so if I were to close those 2 pieces, if it was a piece of paper and I were to close it, makes sense. And what I also suggest you do as well is, if I was doing this in a face-to-face lesson, I would literally say, just draw a triangle on one side, but tilt it slightly, and then see what happens when you rotate it, and reflect it. And no, fourth one, I have to remember which one how many we've done them. The enlargement does what it says on the tin, enlarges. Now, if you're doing high level, you also got negative things in here. So you've got a shape is decreasing. It's a smaller, you're enlarging it negatively. But when you're talking about fractions and things, that's another thing completely. So I'll be doing a separate section on that. So enlargement is basically, it's the same shape, but it's bigger. That's it really. So it's, when you look at it, you can see it sort of, okay, yes, it's still a rectangle, but it was 2 up. It's now 1, 2, 3, 4 up. It was 1 across. It's now 2 across. Oh, it's doubled. And we'll talk about that as well. And what we also have to do is think about where our point of reflection, point of enlargement is, center of enlargement is often called. So where you, and I've put a little torch here, if you stand out somewhere by a light in the evening, obviously somewhere safe, and you look at your shadow, where your shadow is depends on which angle the light's hitting you from behind, doesn't it? So here we're shining the light on. Oh, excuse me, goodness me, it's a bit of a hard day today. So we're shining it on that small triangle, and the reflection it gets on the small rectangle, we get a slightly bigger rectangle after it, and that's because it's shining from basically the origin, 0, 0 there. If we shone the light from somewhere else, we'd get a very different picture. Okay, all right then, so let's just go through a few transformations and see how we work out what the transformation is. So we've got enlargement, translation, reflection, rotation. What did I write? I did come up with like a little, there's not a pseudonym, there's a, whatever that word is, there's a word I cannot remember where you use the first letter of each of the words and it creates something else. Like I use Adam in Sharing by Ratio. Nothing to do with the Adam that I like and my other singer. Anyway, we'll move on. So what's happened here? So we've gone from the blue shape to the green shape. So is it the same size? Yes. So it can't be an enlargement. Next question. Is it in the same position? So i.e., is it sort of, you know, we've got the right angle at the bottom left of the shape, and when in the transformed shape, is that right angle still in that bottom left? Yes. So it can't be a rotation or a reflection. So therefore, it must be a translation. So the translation, again, remind yourselves, it is where we move. It's almost like you're just sort of picking it up and you're just moving it across the page. You're not turning it, rotating it and reflecting it or what have you. All right then, what about this one? So again, we're looking from the blue to the green. Let's go through the same questions. Is it the same size? Yes. So you can see along there, that's 3 and that's 3. So it's not enlarged. Is it in the same position? So looking at them, do they kind of look the same? No. You know, one's turned. We haven't just like physically moved it. We've kind of, there's been some sort of change gone on there. Now, is this a mirror image? Now, I've actually said no, but having said that, I'm just going to look at this now. Just looked outside, I've just seen it's a full moon. It's very beautiful. I'm literally now, I'm putting the ruler on the page because I want, as I'm recording this, I want to make sure that that is not the case. So actually, 1, 2, 3. I actually think that could be a rotation, a reflection. So if I have the line there in the middle, 1, 2.5, 1, 2, that could be a mirror image actually, yes. Now, what we've also got is a rotation. So it has rotated as well. Occasionally, you can get them where they are the mirror image or a rotation. Just be very careful. Oh, goodness me, I think I'll have to cut those little bits out. Okay, what about this one then? I always think this is one's easiest because you can see it's gotten bigger. Okay, so it's the same size. No, straight away, enlargement. That's one of the easy ones. And look at that one then. So is it the same size? Yeah. So we know it's not enlargement. Is it in the same position? No, so we've not just physically moved just around the screen, no. Is it a mirror image then? Yes. So again, it's that sort of imagined piece of paper close together. Right, so where is the line of reflection? I'm just going to go through this now. It's the same question. So what I've done here is I've put a few little numbers on the bottom. Not obviously, this isn't completely accurate because we would have numbers on the y-axis as well. But I wanted to show you how we decide where the line of reflection is and how we communicate that to our teacher or examiner. So what we do is we look at where that midway point is between, obviously, this corner and this corner, this corner and this corner. Draw our line all the way down and then look to see what all the coordinates along that line have in common. Now, when I teach equations of lines, when I'm teaching anything to do with plotting any graphs to do, when we've got equations in them, I say, just remind you, a line is basically a collection of coordinates joined together. And whenever we need a line or a curve, we need coordinates because they are, aren't they? So if you think, right, I plot a dot there, and I can join them together. So what coordinates has this line got? Well, I could pick that one there. Well, I know the x coordinate is 6. I don't know what the y is. Do I need to know what the y is? Just to demonstrate what I'm showing here, no, we don't, because every single point on that line has an x coordinate of 6. So therefore, the equation of the line is x equals 6. Now, I don't know whether I put that in. No, I didn't. Now, just make a note in your revision because the line x equals 6, x equals 2, x equals minus 20, whatever, is parallel to the y-axis. Do not confuse them. So easy to think, oh, it's going up like the y-axis is, but it's what coordinates that line, all the points on that line have in common. A really easy way to find that out. Now, what I'm demonstrating to you without even thinking about it is what happens when you're tired. So, you may miss things or something like that, or you might, oh, I'm a bit tired, I can't quite remember something. Just bear that in mind when it comes to your own study and your own revision, because if you stay up too late revising and trying to remember things, you're going to be more tired the next day, which means the amount of learning you do that next day is going to be affected. Okay, so just something to be aware of and aware how tiredness actually affects you. Now, a translation. Translate by the vector 1, 5. Now, obviously, hopefully most of you, this will be revision. I know a couple of you may never have seen this before. So translate. So when we translate a shape, what we also have to give is what the vector is. And that vector is, and I'm going to show you now, how much it's moved on the x-axis, which is the first number, and how much it's moved on the y-axis, which is the second number. So what I've done here is a really good one to kind of, summarize, especially in revision cards, is that if that number at the top is positive, it's moved to the right. If it's negative, it's moved to the left. So if you picture your x-axis, negative is to the left, positive to the right. So a positive number there means one space that way. The second number is what happens on our y-axis, so the vertical one. So plus a positive number means go up, a negative number means we go down. And again, it's in the direction of the negative numbers on the axis. So let's go back to this question then. I've literally just put this in. So I'm going to show you what we do. So we could literally with a finger, we can go on the screen or on a piece of paper and say, right, I'm going to go right one, up 5. I'm actually going to show you that as an animation. So there's my triangle. I'm going to move it 1 space to the right. And then I'm going to move it 5 spaces positive up. So 1, oops, wrong way. I was pressing the wrong arrow. 1, 2, 3, 4, 5. So that is exactly where it ends up. You could do, I'm going to do 5 up and 1 across. Doesn't matter. As long as the end movement is 1 has moved 1 right and 5 up eventually. Okay. Right then. So I'm just going to do a couple of questions now. So I would like to, so quite often we get asked the question in this way, and I'm just going to move my, there's a little menu thing at the bottom. I'm just going to move it slightly. It says, describe fully the single transformation that maps shape A onto shape B. Okay, now, if you have come across, you've worked with me before, it's a case, right, look at the question. It's shapes. We're talking about transformations. So it's either going to be reflection, rotation, translation, or enlargement. So almost like just have that little ready reckoner at the side, you know, shortcut, you know, do them in abbreviated forms if you want, and then work out which one it is. So looking at that, we can see it is a reflection. So what other information do I need to give? Well, with a reflection, you need to give the line that you're reflecting on. So we can look at the midpoint, draw our line. And on the last one, can you remember how I said we find the equation of the line? Obviously, for some, it's just literally show where the mirror line is. If you have to describe fully the single transformation, you would say it's a reflection on the line. Now, what's it got in common along here? X is equal to -1. If you're thinking, oh, that seems a bit, I need to practice that, just literally look at the coordinates and just maybe write 2 or 3 of the coordinates down, you know, and remember your X coordinate is the first number. Alphabetical order, X comes before Y. Okay, there is one area of maths where we look at Y before we look at X. And it's something to do with lines as well, actually. So see if you think what that is. Okay, what's happened to this one? Can you see? Is it enlargement? No. Is it a translation? No. Is it a reflection? No. It's a rotation. Now, what I'm going to show you is a little tip as well for this. Now, when I'm doing this with a person side by side, what I say is you get some tracing paper. I do have lots of tracing paper. And what I say we do is actually you put the tracing paper over the shape, the original shape, and then kind of just fix that somewhere. It's almost like put your pencil on one place on the tracing paper and just rotate it and see if you can get to where the new shape is. Now, by looking at them, we can kind of see, well, actually here, what we do is I'm comparing 2 of the similar sides. So that's the longest side of that trapezium. I'm looking to see where they both cross. So we can see it's been rotated 90 degrees. It's going that way. So what is that? Now, to be honest, we could have said it's gone that way, 270 degrees. I've chosen to say, well, it's actually going 90 degrees anti-clockwise. So always remember, if it's going that way, it's the opposite way to your clock. So if you can visualize your clock, 12, 1, 2, 3. So going from right to left. This is going from left to right. So it's anti-clockwise. But yeah, literally get your tracing paper, trace the shape, put your pencil on, fix the tracing paper on the paper, and then just rotate it slightly. And I did one with one of my students yesterday, and I said, well, what we do is we kind of just play around, just think, oh, I'll try that place first. Rotated it round, and it ended exactly in this where the transformed shape was. So I'm like, yay! It doesn't often happen, that one. I'm going to show you another example in a minute of how we can find that. Now, what we also have to show with rotation is, so obviously it's the rotation, the direction, the angle, so how much have we rotated it in terms of degrees, and then where we fix the point. So that's literally where you, with your pencil, fixing the tracing paper and rotating round. Okay, so let's have a look at this one. This was an exam question. So describe the transformation that maps A to B. Now, I think we can probably find that one quite quickly. One's bigger than the other. It's an enlargement, okay? And if you are watching this and you are doing higher level, you could be looking at it and thinking, actually, it's smaller. So therefore, it's still an enlargement, but it's a negative one. Okay, so I put a few little points on here. So when we know it's an enlargement, we need to say what the scale factor is, i.e. it's a scale factor of 2, i.e. every side has been multiplied by 2. We also need to say where the light is. So that's like our centre of enlargement. That's the point where we can imagine having a light and we've shone it and we've said, all right, what's created? Where would that point of the torch have to be to reflect on and shape that shape be? And what we do is we literally say, well, for our measurement, first of all, we're going to measure one of the sides and its corresponding one. So here, originally it was 3. Here it's 6. So we can say it's gone from 3 to 6. So therefore it's doubled. So it's been enlarged with a scale factor of 2. Now we need to know where that light is. So what we do is we literally join up each corner from the old shape to the new shape, and obviously continue that line on all the way past the shapes. Same again here, we've joined that bottom left-hand corner, and then we join the right angle part of the thing. And where they cross, that is your centre of enlargement. So that's where the torch must have been to create that B where it was from the A shape. So therefore, again, we go X first, so X 6, and Y is -7. And so we show that as written there. So shape B is an enlargement with scale factor 2, and from the centre of enlargement of 6 -7. That's what you need to give. So that's where your marks go. Now, from marking questions on GCSE maths papers, if you had to say it was an enlargement, you get 1 mark. If you knew it was 2 times bigger, scale factor 2, you get another mark. Okay. If you had to do an enlargement, if you enlarged a shape and you didn't know where to put it, but you did a shape that was twice as big as the other one, you'd get a mark. Okay, so remember, each of these you're illustrating a different aspect of mathematics. So whatever you can show is good. So even if you can't do all of it, but obviously practice papers, past questions, go over your notes, revise, revision cards. That is going to obviously help improve and make sure you remember it when you're in the exam. Right, now I think I'll do the last one here, and then I'm going to do a different question. So shape A is transformed to shape B. So we're starting at A, we're going to B. It was reflected in the x-axis, followed by a translation PQ. Now don't panic, okay? I'm not going to worry about that P and Q in a minute for now. I'm literally just going to do the reflection in the x-axis. So the x-axis is where? It's the horizontal line. So I'm just going to reflect it on there. So that's our mirror. So then and quite often what helps is, again, turning your paper round and sort of doing 2 across, then it goes 2 further the other way. Again, depends how you visualize things, really. So if you put the lines into the mirror line from each of the corners, remember it's got to be at a right angle. So you can see how here, this is hitting the mirror line as a right angle. That one is, and that one is, using the grid lines. So that is, we've transformed that shape. Now, let's have a look at this PQ thing. Because I know quite often it's like when there's nothing that's numeric, I know a few of you will be like, algebra, letters, hard, move on. Don't do that. First of all, come and see me and I'll help you to do what I'm doing now, which is how can we work around it? So what we need to do is we need to see, well, what's happened to go from here to here? Because we know it's moved, we know it's translated to B. Now, what is that PQ thing? You've done your revision and obviously been listening to the rest of this course. That P tells us whether it's moved when it's moved on the x-axis, positive or negative. And the Q tells us whether it's moved on the y-axis. Okay, so they're representing a number that we don't know at the minute, but we can work out. So let's have a look at these then. So let's just compare one of the corners. So this corner has moved from there to there. And obviously the rest of the shapes moved in the same direction as well. So we can say that it has gone 5 spaces to the left and it's moved 1 space up. So 5 to the left, negative. So we need -5 and +1. So we just expressed what's happened from that shape to get from there to there. And we represent it again, knowing what we know about translations. It's negative, it's going left, positive, going up. Okay. Now, so P is 5, Q is equal to 1. There we go. Always remember, letters are just representing a number that we don't know at the minute. Always have that in mind when you see letters, particularly when they come up in like questions like probability, algebra, area, ratio. Just think, what would I do if that was a number? Okay, I'll use the same method to those letters. Just means I won't have a numeric answer, but that's okay. Right, so I'm actually going to do this one now. So how can we tell how much something's rotated? Well, I've told you straight away now it's a rotation. And what I've done is I've just joined up 2 corners. So the corner of the right angle in the first shape, the corner of the rotation in the second shape. Look at the angle between them. What is it? The right angle. And we can say it's rotated that way, so you can always visualize it. And again, if this is an exam, get your tracing paper, get your shape, move it to the second shape, fix your point, work out where it is. Now, quite often they are in relation to 0, 0, the origin. You can kind of see, well, that corner is 2, 2 away from there. This corner is 2, -2 away from there, but the length is 2, 2. So you can kind of see it was fixed at 0, 0. If not, just say put your pencil in places and just rotate, see where it ends up. So it's rotated, 90 degrees, clockwise, with the center of rotation as 0, 0. Right, I'm going to move on now. I'm going to leave that one. But I'm just going to show you that quickly. Because it talks about, on this shape, it talks about clockwise, 180 degrees. Do we have to state a direction when we're rotating something 180 degrees? We don't, because actually, if we rotate 180 degrees anti-clockwise, we'd end up in exactly the same place. And what I suggest you do is literally, you can see what I've done is literally drawn lines. So I've drawn lines from each corner to the center because it says about 0, 0. And then I've done the same line in the opposite direction because that's what 180 degrees is. You're kind of going all the way around. You're creating that little semicircle. And that is, I always say to people, if you can't remember what 180 degrees is, get your protractor. Mine's a bit snazzy, but it's not that practical, to be honest. It's like that semicircle. And so when you're 180 degrees, you will notice that each side is almost like it's rotated round to the other side. So it's like tip round, so it's facing the opposite direction, okay? When you do 90 degrees, it goes from rotating to the side to up, or maybe from up to the side. It's just like one turn, really, 1/4 turn. 180 degrees, you're going to turn it round to the other side. Okay, so again, what we're doing here is if we're rotating something 90 degrees anti-clockwise, which is the one at the bottom, that's what you're going to get. Again, it's sort of almost like take the lines. Imagine you're holding this line here, each side, and you're turning it 90 degrees. So you're just turning it one quarter turn, sorry. All right, just to finish off then, if there's anything in there that you think, but that didn't answer my question on a topic I've seen recently on transformations, pop me a message. And what I'll do is I'll add it to the end of this so that then when I do this again, it's in there ready for you. So what have we got? Let me just checking something now. So this is from the Oxford and Cambridge exam group. I think what the RR is, I'm sure it's Oxford and Cambridge. And it's paper 1, so it's foundation level, up to a grade 5, which is a good, a low B. Now, Mr. and Mrs. Jones buy cinema tickets for themselves and their 3 children. The cost of an adult ticket is £6 more than a child ticket. The total cost of the 5 tickets is £45. Work out the cost of an adult ticket. Now, you might look at this and think, I know what to do. Go ahead and do it. You know, as long as you use a method, you're using legitimate mathematics, that is fine. This is 5 marks for this question. So when you look at a question like this and you're like, I don't know where to start. So what we have to do is then think, well, what do we know? The questions are not impossible, okay? Even if you're looking at it thinking, I've got no idea what to do here. I want you to instill into yourself that actually there is something I can do here. And as long as I've done my revision, and if it's getting a bit woolly and I'm thinking I can't think of anything, just take some long, slow, deep breaths. Just calm that nervous system down as well. So again, if you've revised, just remind yourself there's something in this question that I know I can do. So do we know the cost of an adult ticket? Now, it's a 5 mark question. So I'd like to think that actually it's not going to be that simple. But each of the steps might just be quite simple maths to do. It's just there's 5 of them, or 4 and then the answer. So we don't know the cost of the child ticket, so just give it a letter. Because remember, what do we do when we don't know something in maths? Apart from moving on to the next question, is we give it a letter. Because then we've got something tangible that we can work with. So what I'm going to do is think about, well, what do I know? Well, I know that there's 2 adults and 3 children. I literally did this about an hour ago, and I was looking for a nice little picture, and I was like, no, I'll just leave it. I'll put what I know, which is 2 adults, 3 children. Okay, what else do we know? Well, it's talking about the cost of a ticket. And what I like to get students to do when they're looking at questions is like, well, just try and summarise, what's it about? If you were to describe, it's a question about the cost of a ticket in the cinema. So, well, we don't know what the child cost is. So, but we're going to give it a letter. So we're just going to call it C. Could call it X. You could put just a little question mark if you wanted, and a symbol, whatever you want to do, but as long as it's the same for each of these. Okay. Now, what do we know about the cost of an adult ticket? Well, it's £6 more than the cost of a child ticket. How much is a child ticket? I don't know, but I'm representing it as C. Okay, so what's 6 more than that? If you knew what that was, say it was £10, what would we do if we said, well, it's £6 more than the child ticket? We'd do 10 plus 6, yeah? So can't we just do the same with this letter? So it's whatever it is, which is C, the temporary letter I've given to kind of denote it. Add 6, C plus 6. Because when I know the C, I can add the 6 on. And then adult, another adult. It's about having that confidence that, okay, this is representing it. I don't know the answer at the minute, but I'm representing it in relation to each other. So I've got 3 children, and then I've got an additional, effectively, £12 on top of that for the other 2 adults. So you've got the 2 adults and then the extra £12 on top for those extra 2. So total cost of the 5 tickets is £45. Total, what does that mean? So when you see the word total, what maths would you do? Total, sum, add. Yep. So if we add all those together, we get £45. This is where I know a lot of students would be like, but I don't know what it is. Yeah, we do. We know they add together to give 45. And we've said that, okay, we don't know what the child cost is actually numerically, but we're letting it be a letter. So we've got something that we can create a little equation with, okay? And it's about having that confidence of just having a go. We don't know what it is at the minute, but that's fine. We've just taken what's in the question, represented it mathematically, so using maths language is what I like to call it. Okay, so we've done that bit. Right, so have I answered the question yet? No. So it's kind of like, well, what maths can I do with what I've just done? So is there anything I can do that I've learned that when I've got two letters, I've got sort of, hang on, I've got like 5 of these C's and I've got a 12, I've got a 12, a 6 and a 6. 6 plus 6 is 12. So I can do that. I can add those 6s together, those 2 6s. And I know collecting like terms. So I've got a C and a C, 2 of them. And I've got a C and a C and a C. So I've got another 3 of them. So I've got 5 of them altogether. So I've got 5C plus 12. And remember, what is C? It's the cost of a child ticket. And I know that's equal to £45. Questions like this come up quite a bit in GCSE maths, where we actually know an answer, i.e. the total cost is 45, or the area is this, or what have you. And we have to kind of create an equation with something that I don't really know what it is, i.e. the height, here, the cost of a child ticket. And what we do is we kind of rearrange it to find that thing that we don't know. Okay, so, and I'll do loads of these on the maths club because it helps build that confidence. So 5C plus 12 is 45. So I'm just going to say, well, actually, have I answered the question yet? Well, what maths can I do with that one? So actually, C is the thing I need to find. 12, well, that can go over to the other side. I want C on its own on that left-hand side. So I'm going to get rid of the 12. And I'm going to take 12 away from both sides. Remember, balancing scales. Whatever you do to one side, you've got to do to the other, or it won't balance. Then, to get a C, at the minute, 5 is multiplying it. So to cancel that out, we need to divide by 5. Do the same to both sides. And we get £6.60. That's quite conclusive, isn't it? It's like C equals £6.60. Yes, I've answered the question. But have I? No, because the question was saying, work out the cost of an adult ticket. So, well, okay, so let's go back over here. Where was I? And sometimes once we've done a bit of work and it's a bit abstract because I've had to stick letters in there, I then have to think about, yeah, it's the cost of an adult's ticket. It's something real and actually quite tangible. So the cost of an adult ticket, well, adult ticket is 6 more than a child ticket. And we quite often have to go back over the question to remind ourselves what else is there, because we've got a few more pieces of the puzzle put in now, haven't we? So have I answered the question? No, because I know the child price. I just need to add £6 on. So the cost of an adult ticket is £12.60. Does that make sense? £12.60. Is that right answer? What can I do to check? Well, if I've done it right, I can do 2 of those, which is £25.20. And then I need 3 of these, so £19.80. Add those 2 together. I get £45. So again, we can add them, we can find out, do we actually get the right answer? Now, what I'm going to do now is I'm just going to stop sharing now. So you'll get this off the screen and you'll see me in full pace. So hopefully with that, you've got a good idea of the transformations, a little bit more confidence with knowing what to do on a question whereby you don't know something. So what can I do? I need to have something that I can do something with, give it a letter. If you know how something's been calculated, put them together, rearrange, solve the equation, get C. And yeah, you might not get something like that again. You might have something completely different, but it's about the method that you're using. You will see time and time again. So when you're doing maths, think, rather than, oh, the answer's 12, think, okay, what maths did I do to work out that 12? You'll probably come across a lot of maths between now and your GCSE. So yeah, think about, what method did I use? What method did I use? Because those methods are the things that get built on and built on and built on before, you know, as we get harder and harder in maths. Okay. Any questions, please let me know. And if you want to be in the next masterclass next Tuesday at 6:30, let me know. Thank you very much. Thank you for watching. Bye-bye.